What's up, Chunk Slayers? It is Spicy Monday, and I am coming at you today with your favorite thing, some math. To start it off, I got a question for you. Just because something has always happened a certain way doesn't mean it has to keep happening that way. When's the last time you took a step back and checked if you're in a Bayesian trap? I've had the fortune of talking to a lot of MSPs over my career, and I cannot tell you how often on any subject I get in front of an MSP, they tell me what's wrong, I make a suggestion, and I either hear we're already doing that or that'll never work. Both of which are really amusing because if you were already doing the thing I suggested, you wouldn't be having the problem you said you were having, or alternatively, if you just did the thing I said to do, the problem would go away. And there's a whole host of reasons why people cross their arms at that, but one of the big ones is actually an interesting concept that involves probability math and our innate inability to properly understand how probability sample size works. So we're going to talk a little bit about Bayes' theorem today, and don't worry if that sounds boring. It ties into other stuff that you do all the time. Stick with me, my friends, while we get a little mathy. But let's say you go to the doctor because you don't feel well. They run some tests and you test positive for a very rare disease that affects 0.1% of the entire population. That'd freak me out. So naturally you ask the doctor, how certain are you that I have this? They say the test will accurately identify 99% of the people that have the disease and incorrectly identify 1% who don't. So that sounds like you're screwed, right? What are the chances that you have this disease? 99%, right? You tested positive. But that's not actually how the math works. And we'll show this with Bayes' theorem. And don't worry, I'll put it up on the screen. Bayes' theorem gives you the probability that a hypothesis that you have that disease is true given an event that you tested positive. And you take the prior probability the hypothesis was true. How likely did you think you had this, and multiply by the probability that you would test positive if you do have the disease. And for the sake of example here, you're just a regular person. You're not going out anywhere crazy. You're not, going to uncharted islands. So you think it's highly unlikely you would have randomly contracted this. You take all that data, you divide it by the probability of anyone having the disease to begin with, which we already know is 0.1% because we have enough previous examples to support that data. Sometimes that bottom variable is just a guess or anecdotal. And in the case of MSP stuff, it will likely be anecdotal. In this case, if you plug all that in, it turns out you only have a 9% chance of actually having the disease after testing positive, which is way lower than you were all thinking a little while ago. And it's kind of crazy, right? Because a test that is 99% accurate where you test positive would make you think that you almost have a 100% chance of having the disease. But in actuality, it's a 9% chance. And if we take that same example and just apply it to kind of common sense, because that can all sound too mathy. Imagine you catch the con flu or think you've caught the con flu at an MSP event. So you're at a show, there's 1,000 people there, and we know for a fact one person out of that 1,000 has the disease, and this test would correctly identify them as having it. But if you're one of the other 999 people at that show, well, 1%, because remember, there's a 1% error here, or 10 people, remember, the test was 99% accurate, 10 people would falsely test positive along with the person who actually tested positive. So if you're one of those 10, plus that sick person, you have a 1 out of 11% chance of actually having it, which is only 9%. So you can see right away that an advertised percentage of accuracy does not equate directly to a percentage of effect. So that whole idea of you actually only have a 9% chance of having this disease, even though the test is 99% accurate, and that therefore does not mean a 99% chance of having the disease, that's called base rate fallacy. And that can cause a lot of problems when it comes to adopting ideas and interpreting patterns of past successes or failures. And in this case, I'm more interested in failures when you are interpreting past failures. And there's some ways you can think about this pretty practically. Imagine you have a security tool, and that security tool uses some sort of AI algorithm to analyze behavior, as we've seen become very popular now. It's not using the old-fashioned detection library, and the tool says it's 99% accurate, which sounds really good. But if only 0.1% of all the devices across your entire base have some sort of detectable malware on them, the majority of positive alerts are probably false alarms. There is a certain tolerance for this we're okay with, right? In that context, sure, I'll take a couple positive false alarms that I investigate, and turns out that they were wrong. But you notice what I said there. In the case of that security tool, you understand that it's reasonable, that a certain amount of those alerts are going to be inaccurate, and you're going to take the time to investigate that, and you're going to take the time to move forward. How often do you do that with the rest of your business? How often do you do that with the rest of the way you approach your decision making at your MSP? Having met a lot of you, I would say not very often. The idea with Bayes' theorem and the idea with approaching probability or an algorithm from a Bayesian standpoint is that more evidence improves certainty. And that's really, really important, because a lot of times if something works the first time, or if something fails the first time, or if something works a couple of times or fails a couple of times, we write it off as either being empirically successful or empirically a failure. And I see this a lot. It's one of the biggest resistance points mentally that's going on when people in this channel get upset about like thought leaders or coaches or whatever basically saying there's a particular format to follow for success. And the part that they're leaving out is basically in a rush to say, well, that didn't work for me. No, it didn't work for you once. And there's also a reason why that coach who's had it work for 1,000 people or 5,000 people or 10,000 people is telling you that's a repeatable way for it to work, because they've had it work with way more sample sizes than you've had it fail. We see this a lot with marketing. We see this a lot with sales. We see this a lot with operations. We see this a lot with hiring. We kind of see this a lot with everything. And it's actually one of the main reasons why I'm such a huge advocate of not being alienated from the channel when I meet business owners that don't do anything, because you are limiting your sample size of information to actually make appropriate justifications around your decision making. Slightly more practical examples of this I can give you. How many of you have had somebody over the course of your entire business history where you have interviewed somebody or interacted with an employee level person before you hired them, and your first interaction with them just wasn't that great, and for whatever reason you interacted with them again later and then eventually hired them and they turned out to be a great employee? Or the far more common, how many of you have had a great interview with somebody and they've turned out to be a stinky employee? In both cases, we took a very limited amount of data, one interaction, one interview that either went negatively or went positively, and then we use that to make assumptions and apply to the totality of how that employee is going to perform, which, as you know, is not always accurate. And if we had a chance to have more interactions with that person before we brought them on, we would make a more accurate assessment. That is applying Bayesian logic to that problem. Here's another one I know you've all experienced. You get one user from a client calling in and reporting something as being a major issue. And what is rule one of triage? Well, we got to find out who else is it impacting, right? We already know that. That's Bayesian logic, because we know that one person saying it's broken may not actually mean it's broken everywhere. And until we have more data points to sample from to compare against the probability of it actually being broken, we probably shouldn't overreact. We use this sort of Bayesian thinking all over the place. If you've used a half-decent spam filter on your email in the last 15 years, it used a Bayesian algorithm to understand that if a random email address that has never emailed me before emailed me something like free money, that's probably spam. But if my boss emails me that, who I get a lot of email from, the words free and money probably aren't immediately indicative of spam coming from my boss. In fact, Bayesian filtering works so well that people started learning how to gamify that, which is why phishing started, and basically going and trying to now email and spoof an email address that's more trusted to try and gamify that system. Here's where it starts to become problematic, I see, at a lot of MSPs. We tend to take emotional decisions or desires of what we want our business to be, or emotional reactions to problems we've had, and we tend to apply those as basically holistic assumptions to the entire category of that idea. We see it all the time if you go on Reddit with employees who will all parrot that time entry is bad. No, it's not. One place you worked who interpreted it improperly did it poorly. The rest of the industry doesn't, and that doesn't mean that we now don't track time, but look at how many people based on one experience have decided time tracking is bad and they're never going to do it. How about SLAs? How about a 99% uptime on an SLA? If the client experiences downtime once, does that mean the MSP failed? Probably not. And all of this is applying this idea of Bayesian thinking, where we are making sweeping decisions around a very limited data set, and oftentimes not giving ourselves the opportunity to either repeatedly succeed or repeatedly fail at something to really understand what it is that we're doing wrong. And so that brings us into this idea that we tend to do something. We tend to overfit to experience. We tend to want to internalize past experiences and assume they reflect an unchangeable reality. And this is tricky because being able to take past experiences and use them to generate intelligent assumptions is part of what makes you a professional. Being able to intelligently make assumptions based on past experiences and things that fit them is a skill, and it's a skill a lot of us have, but we tend to put way too much value into it, and then we end up in this very, very interesting world where if you fail at something repeatedly, you start believing you will always fail at that thing, which statistically and probability wise is ridiculous. Of course, that's not possible. That if I fail 5 times at riding a bike, that doesn't mean that I am permanently going to fail at riding a bike. It just means I failed 5 times already, and I need to modify my approach. Me being completely incapable of ever riding a bike is so infinitesimally statistically small, it is almost impossible that I will not be able to ride a bike. But I'm assuming that it is almost 100% possible that I can't, because I failed every time I've tried so far. And it really, really can screw with how you think about problems. And this doesn't really matter about how experienced you are, how intelligent you are. It has nothing to do with intelligence or experience. It has nothing to do with skill. It's how your brain works. And all of us can fall into this trap really, 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 really easily. You ever hear that idea that there's no point in debating someone who is either 100% confident or 0% confident in an idea? That's Bayes' theorem. That is literally Bayesian thinking, because you are basically saying that person has already taken a very limited set of experiences and come to 100% probability calculation in their brain, which doesn't really matter how many alternative versions you bring in, because if you actually do the equation we looked at earlier, it's going to come out for them as 100% or 0%, so you won't get anywhere with somebody that's that entrenched either way. You know this at Thanksgiving, not to have that fight with that relative over that political topic because of how entrenched they are. That is Bayesian thinking. And so here's a really great example of this. How many of you have shitty clients? And the advice you get is charge more or churn them. And we kind of laugh at that because we know our shitty clients aren't going to pay more. We probably have them maximized to the maximum value point that they will pay. And well, I can't fire them all, I need revenue, right? How many MSPs then sit in that sort of stasis mode in perpetuity until the owner retires or something else at whatever that ceiling is of the MSP, $1 million, $3 million, $5 million. You all know what I'm talking about. That is a lack of applying Bayes' theorem properly. You are going in and assuming that you are stuck with bad clients because higher paying clients will never sign on. Of course they will. It's the same logic where I hear people saying, well, my clients would object to that, or that won't work. What are you talking about that won't work? What are you talking about they'll object to that? How do you know? You haven't even let them object to that. The flip side to that is the MSP always discounts before they walk into the room because they assume someone will fight their price. How do you know? How do you know unless they actually fight the price? All of that is a misuse of Bayes' theorem with your decision making, and you can see just from those examples that probably apply to nearly everybody who is watching this video in some way, how much that can trap you in how you were thinking. And here's the key, because this isn't a magical wake up and manifest success. The idea is just because you've only landed small contracts before doesn't mean larger deals are impossible. You just have to try a different pitch or move to a different audience. That's the important part with Bayesian thinking. You have to start experimenting. You have to start repeating the same behavior, but trying a piece of it differently over and over, changing things, which increases your sample size until suddenly you don't fail, because the probability of you failing is way, way, way lower than you have convinced yourself that it is. Just like the probability of me actually having that rare disease on a test that's 99% accurate that I test positive for is still incredibly low, only 9%, incredibly low. And think about that with your MSP. How much shit have you written off as it will not work, or it won't work for me, or I don't know how to do it, because you tried it once and it failed, or you tried it wrong and it failed? How many times have you given up on something that you've tried 4 or 5 times and it's failed and not seen it all the way through? Yes, I know sunk cost fallacy is a thing. There's a whole bunch of reasons here you got to be careful. And I am not advocating you throw caution to the wind here, my friends, but I do want to point out that sometimes our brains work against us here, even if we know what we're talking about. Nelson Mandela had this quote, right? Everything is impossible until it's done, which, of course. And we know this with science, that things don't exist or aren't possible until we discover a way for them to exist or be possible. We know that all sorts of quantum math says there are calculatable probabilities for the most random. There is a mathematically calculatable probability that a giant T-Rex dressed in armor will manifest next to me, speak perfect English, and finish this video right now. That is mathematically possible, even if we know it almost certainly won't happen. We know all of this, right? But yet we give up on stuff all the time. We don't try things all the time. We cross our arms and refuse to listen to people that can show us a path that has repeatedly produced results, because once or twice it didn't work for us, so we assume it doesn't work. Think about that. Think about all the times you've crossed your arms at industry advice. Think about all the times in any capacity you have heard best in class, a KPI, a metric, an SOP, the right way, the best way, and you have sort of bucked the trend. And I don't mean because you're one of those people that just wants to be different than everybody. I just mean you've looked at that and you've been like, yeah, I tried that and that didn't work, so therefore it doesn't work. Okay. And how's that going for you over there? 15, 20 years in business at the same size you've probably been for the last 10 years. Pretty good, right? Maybe it's time to start thinking if you've kind of locked yourself into the wrong interpretation here of Bayes' theorem. So my friends, on this Spicy Monday, I don't want you to go out and do stupid shit. I'm not trying to encourage all you entrepreneurs to go find the one friend of yours that did something really stupid that kind of succeeded for that one friend. That is not the point of this video. And if that's what you heard, go to the beginning and watch it again. What I am telling you is that if you look at the industry, and the industry has a repeatable way to achieve success, and there are many examples of people who have been successful on that repeatable path, but you haven't had success on that repeatable path, it's time to try it again. Odds are you are not going to keep failing at it if you keep following it, because statistically the math doesn't support that you suck that badly. You need to keep trying, and you need to experiment, and you need to change small things and keep getting on that bicycle, because eventually one of the times you get on that bicycle and start pedaling, you will not fall over and scrape your knees. But if you quit now, you will only know, I can't ride a bike and my knees hurt. Who wants that? So I know it's not the spiciest hot take on a Monday, but maybe, just maybe, if you have some problems at your MSP and the rest of the industry, a coach, a vendor, another business owner tells you, gee, I don't know anyone that has that problem, and all the people that did followed these steps and they no longer have it, maybe don't cross your arms this time and say that'll never work, or I've already tried that, or we're already doing that and it fails. Maybe apply Bayes' theorem and recognize that the actual possibility, the percentage that you're going to keep failing, is incredibly low. You've had a little bit of bad luck so far. Try it again. It's far more statistically likely it'll be successful if you keep trying. Stay spicy.